All right, it's 11 o'clock. I think we'll get started. I guess the mic is important for the internet people. Sorry to people in the room. So today is our final seminar of the first semester seminar series, and we have an excellent speaker to close it off. We have one of our PhD students, Yadav Padyoti. Yadav is a year and a half into his PhD and has already completed a couple of studies. I ask with a question. He's been very efficient, very effective, and he is doing his PhD in part as part of the ARC Training Center for Behavioral Insights and Technology Adoption. And today we're going to be learning about the price of wheat. Is that correct? Great. So I'll hand it over to Yadav. Have you turned the microphone on? Excellent. So I have been informed that Yadav thought it was supposed to be a 30-minute presentation. So I think I'm going to let it go on for 30 minutes. If anyone has to leave after 30 minutes at the start of question period, you are free to leave. But I'm going to break the rules. Please don't tell on me.
Thank you, Curtis.
Absolutely. Questions constantly.
Thank you, Curtis. Thank you all for joining me today here in person and online. So I'm Yadav, and PhD student here at ARE. I'll be talking about my results from my first paper today. It's about efficiency of wheat markets in Australia, and I'm using GARC-based in-utero testing procedure. So I can finish a little quicker. I can be a little quicker if you want. I'll try to do that in the process. So I'll start with a little overview of the wheat industry in Australia. Australia produces about 25 metric ton of wheat annually from 12 million of hectare, and it is about 3 to 5% of global wheat produce. And WA is a leading wheat producer, followed by NSW, South Australia, Victoria, and Queensland, respectively. So Australia is also a dominant player in global wheat trade. It trades almost 65 to 75% of total annual produce, and that accounts for 10 to 20% of the global wheat trade. And wheat is leading export earnings from agriculture sector. And the top 5 destinations for Australian wheats are East Asian countries ranging from Japan to China to Japan. So when you see the history of wheat marketing in Australia, before 1939, there used to be small cooperatives engaged in marketing system. After that, government established state-owned enterprises called Australian Wheat Board, and that was established by Wheat Industry Establishment Act 1948, and that was amended time to time. But it was a kind of monopolistic institutions. That was the only single desk where producer used to sell the produce, and that AWE used to market their wheat inside the country or outside the country. So by the time 1989, government came with Wheat Marketing Act, and that partially deregulated the Australian Wheat Board. And what that did is that opened the domestic market for private traders and other cooperatives, but that was still a single desk for exporting wheat from Australia. It was only 2008 the state-owned the partially deregulated wheat board was deregulated completely, and by then only a number of other traders could enter in market. But it was only 2012 it was kind of fully deregulated, because until 2012, from 2008 to 2012, there was a kind of accreditation system for the traders to be into the trading system, and that kind of had created some kind of a trade barrier for the traders, and that lifted in 2012. So the motivation of this deregulation worldwide, even in Australia, is encouraging competition, transparency, and efficiency. And how does this deregulation system encourage efficiency in market is by 2 mechanisms. First, they welcome multiplicity of traders, and these diverse traders brings information sources from diverse background, and that kind of creates efficiency in the markets. So another one is, since these are deregulated markets, there is a free trade, there are different other mechanisms by which they are integrated with other regional and international market, and the information flows from regional and international market, and that also creates efficiency in the market. However, there is still concerns from the farming communities and market operators and market participants about the transparency of the grain prices and wheat prices in Australia. For example, hot reports about the NSW farmers president commenting about raising concerns about the transparency grain pricing, and also one of the online trading platform operators, Nathan Cattle, also raises the concern about the transparency of the prices in Australia. In this context, it's worth asking empirical question whether these Australian grain markets are efficient or not. When I say efficiency or market efficiency, it can refer to different meanings, but what I'm trying to discuss here is about the random walk properties of the market prices. So this is explained by Pharma, which is theoretically linked to efficient market hypothesis. What this tells is the commodity and asset prices reflect all the information underlying the value of that commodity or asset, so that it is not possible to simply analyzing the information about that commodity to predict the futures behavior or movement of the prices. So he explains this efficiency in three forms. So one is weak form efficiency, another is, which is about relationship between past price information and the current price or future price movement. So another is public information and the price movement. Another is strong form efficiency is private information about the commodity and the price movement. So I'll be focusing on weak form efficiency here in this study. So when I surveyed the agriculture economic literature, so most of the literature focus on efficiency of futures market, especially for the ability to unbiasedly and efficiently predicting the cash price or spot prices. But there are limited literature in terms of assessing the efficiency of spot markets. And this gap is even more pronounced for Australian context because Australian wheats or Australian grains are thinly traded in futures market, and the spot markets themselves are kind of source of price discovery for Australian grain and Australian wheat. This kind of assessment also has a significant policy relevance because market efficiency is instrumental in terms of promoting equitable welfare distribution along the grain value chain. Because if there is no efficiency, that means there is no competitiveness. So in that case, some of the traders who has disproportionate access to information or technical capability to analyze this information can have abnormal profit, compromising the welfare of other market participants in the value chain. There is also methodological gap in agriculture economics literature. The financial economic literature is very much advanced in this kind of analysis, but agriculture economics literature are more concerned or focused with the conventional unit root analysis, and they lack these conventional unit root analysis lack the capacity to account for statistical issues that is induced by climatic shocks, economic shocks, or crises, or other shocks. And what these shocks do is they introduce trends, structural breaks, or heterogeneity. By heterogeneity, what I'm trying to say is changing variability of the price risk over time. They introduce those things, and these things are not actually the unit root properties in the price series, but they mimic the unit root properties, and they, if we do not control for these structural breaks, heterogeneity, they can create a spurious results, or they can distort the interpretation of the results. So theoretical framework, so I'm using a weak form of efficiency and integrating it with unit root analysis. So the relationship between past price and current price can be modeled with these first equations, where current price is explained by the drift, trend, past price, and the error term. So the assumption of the uniform efficiency is the drift coefficient of drift should be 0, coefficient of trend should be 0, but the coefficient of that past price should be significantly not different than 1, and the error term should be shouldn't have no serial correlation, or it should be identically independent and identically distributed. So this is the pure random walk assumptions for implicit market hypothesis. As I explained before, so I'm also controlling for those trends, structural breaks, and heterogeneity. For that matter, I'm estimating this unit root analysis in GARC framework. In that, I'm jointly estimating this AR autoregressive model, which is equation 1, and the volatility model, which is equation 3, jointly or simultaneously. So in that DBI, what I'm doing is I'm controlling for the structural breakpoints. I'm creating dummies for those structural breaks and introducing here to control for those. And here, these control for the heterogeneity or the volatility. So for empirical strategy, I start with the conventional augmented Dickey-Fuller and Philip-Perron test without trend. And I test for the trends with simple OLS regression with trend variables. If I find that, then I go for I extend that ADF and Philip-Perron test by including the trend. And then I test for the structural breaks using Bai and Perron 2003 multiple structural break test, and also test for this heterogeneity using the Lagrange multiplier test. If I find those, then I go for the Naren and Liu 2015 GARC based unit root test with structural breaks. If there is no arc effect, I go to the Naren and Pop unit root test with structural breaks but no GARC. If these are not present, this is enough for this unit root analysis or testing for random walk properties in the price series. So this is simple illustration of equations based on those empirical strategies, where that is the ADF test. The only difference between theoretical framework equation and this equation is I've introduced this difference lag version of derivative of yt minus 1. That is for controlling for autocorrelation in serial correlation in error term. That is same with these equations. So data, I'm using the APW1 with daily spot price series from 6 Australian port markets, 4 from Western Australia, from Geraldton to Esperance, and Port Adelaide from South Australia, Geelong from Victoria. And the price information are extracted from Bloomberg data repository terminal that is present in UWA, and it was provided by the Profarmer Australia to the Bloomberg. And the study period is 16 April 2015 to 2024, April 2024. If we see the price series of Australia, so there is some kinds of co-movement between these port prices. This is the WA prices, 4 WA prices, and that is Kwinana, Port Adelaide, and Geelong prices. And there is clear upward trend. So there is a clear upward trend in the price series over these 10 years. When you see the summary statistics, this average price is about $326 to $335 in different port zones. They range from $213 to $550 during these 10 years, and prices are positively skewed and plateaued. And when I test for the normality of these price distributions, they are not normal. I start with the results from the conventional test without trend. So when I estimate this ADF and Philip-Perron test without trend, the null hypothesis of unit root is not rejected. That means they exhibit the unit root. That means we cannot predict the futures movement of the price based on the past price informations. That means we accept the weak form of efficiency without trend. Since we see the clear upward trend of this price during this 10 years, I test for the trend, and the trend is positive, significantly significant and positive. And since they are significant, I introduce that trend into the model. And when I introduce that trend into the model, then OWA prices reject the null of unit root at 1% level, and the Port Adelaide reject the null of unit root at 1% at 10% level, whereas Geelong price still has unit root, but trend is also significant there. So they reject the null of unit root, but Geelong still has the unit root. That is trend. That shows the trend random walk with trend properties. So with this trend, they lose the unit root properties. That means WA price are no more efficient now. So I have control for the autocorrelation with the optimal level, optimum lag selections. They range from 10 to 18. So Albania and Kwinana, I've selected 10th lags, and for Geraldton it's 14, and for maximum is for Esperance, which is 18. So I've also tested for homoscedasticity with Lagrange multiplier test, and that rejects the homoscedasticity, clearly saying that there is change in variability of the error term over the time. And that can be seen in this graph. This is simply the difference or the return prices, where you can see there is a volatility and there is also a clustering of volatility. So there is a change, there is in variability over time. Some episodes are quiet and some episodes are quite noisy. So this is what I was trying to say about the heteroscedasticity. When I test for the structural breaks in this price series with Bai and Perron 2003 test, I find 5 structural breaks. And first breaks are, when you see these breakpoints, they look pretty intuitive and they relate to some events going on in globally and domestic scenario. So these are pretty intuitive. If you see, these are the breakpoints. This red line shows the breakpoints, and these red lines are exactly at the point where there is a start of increase or a start of decrease. That is the break. So first breaks is around December 2016 to March 2017. When I was trying to see what are the major events that is going on in global wheat market, what I find is there was a huge price hike in bars rate in USA, especially in Mississippi River. What that did is that increased the price of US wheat, and that reduced the contribution of US wheat to the global market, and that created higher demand in the global market, and that increased the maybe Australian wheat prices. So next one is April to July 2018. So that is a significant yield loss period due to extreme and prolonged drought in Australia. So that created the upward movement of prices in Australia for Australian wheat. Another is in April 2020, that's a period of widespread lockdown due to the COVID-19 that created supply chain disruption all over the world, and that also pushed the grain prices up. The next one is pretty much exactly fourth and fifth breaks are exactly at the same point for all the price series. So fourth one is August 2021. That was the bumper period for Australian wheat. Even though there was an increased yield in that period in Australia, but there was a drought in North American countries and reduced amount of wheat was there to the global wheat trade. And also there was heightened demand in Southeast Asian countries that increased the price of wheat during that period. The next one is December 2022. So I was expecting that to there would be some kind of breaks around July 2022. So that was the time when there was a Black Sea grain agreement, because Black Sea grain is one of the biggest competitors for Australian wheat. But actually, Australian wheat didn't respond that much. That could have responded, but that was not very much significant. But it waited for some time, and it responded after November 2020, which is December 2022. November 2022 was the period when that Black Sea grain agreement was renewed, and that renewal kind of pushed the Black Sea grain to old market, and that reduced. That is the competitor for Australian grain. That reduced the price of the Australian grain. That is the point that Australian prices plunges down. When I include all these structural breaks, trends, and heteroscedasticity, uh, uh, in GAC-based unit root test with the structural breaks, what I find is unit root null hypothesis is rejected for all the 6 price series of Australia. So now there is no unit root. That is past price can predict the futures price, and that rejects the weak form of efficiency. I'll come to one of the questions that Dave asked earlier about these structural breaks and afterwards. It implies that which Australian wheat spot prices are mean reverting, past price information can predict the futures price, and rejecting the weak form of efficiency. So that means that suggests that Australian wheat market may not be functioning optimally, potentially benefiting some technically adept large traders while disadvantaging other producers or consumers. We don't know yet whether these asymmetry is positive or negative. So what this highlights is the needs for the policy interventions, such as promoting the transparency and reducing information asymmetries. That could be done through establishment of centralized commodity price database, which could allow for real-time, ensure real-time price reporting, historical access to historical prices, inventory levels, or the production forecasting system, so that that can help the farmer to decide their marketing decisions. Also, policy also encourage the competition and prevent oligopolistic or monopolistic practices, and increase the adoption of risk management tools such as expanding futures markets for Australian grains, and enhance the regulatory framework by regularly assessing the persistent inefficiency in the market and implementing continuous correction mechanisms. So we have not disentangled the causes of these inefficiency in Australian wheat market, but future research could explore the asymmetries in transmitting price signals between Australia and global trade. And also, these inefficiency are not only influenced by market fundamentals, the behavior of market participant also can have impact on efficiency, and the behavioral exploring the behavioral pattern among the market participants in responding these price signals would also help to know about these phenomena in broader sense. Thank you very much.
Thanks, Yadav. Great job with timing. Great job with recovering with the PowerPoint shutdown. Either 4 minutes over or 6 minutes under, depending on how you look at it. Do we have any questions from the room? Yeah, Michael.
There's certain sort of systematic patterns you'd expect in the wheat prices, because just the seasonality of production. So you'd expect to see prices dropping when the new harvest appears. How does the analysis allow for that? Does it pick that up? Or I couldn't see anything in there which might talk about what you might expect in terms of seasonality. Trends, structural breaks, but no seasonality. Is there?
Well, that was the first test I was running for, but what I found is there is less effect of seasonality. It might be because these Australian wheats are globally traded, and since there are free trades and global trades and integration between regional and international market, what that does is that kind of reduces the impact of seasonality and biological nature of these things in the prices, especially for producers like Australia, whose grains are traded globally.
And wheat is easy to store.
Yeah.
The easy storage of wheat.
Yeah. With easy storage and continuous trading, like a phenomena, that kind of reduces the seasonality effect.
Tried it, put the seasonality in, doesn't seem to have any impact, doesn't change your conclusions about what might be driving the the inefficiency.
So were you working with daily settlement prices, or you are using seaborne prices, right? Or
And it's not a seaboard price, it's a local price.
but the futures is into how long in the future that you're predicting?
So the future, I'm not predicting the future until now. If I forecast how long does it take to dissipate the impact of past price shocks, we could see that from this one. So for example, for Geraldton, it takes 31 days to dissipate the past shocks. For Quinana and Albany, it's around 14 to 7 days. So I forgot to tell two things here. So Port Adelaide model for GAC 11, it explodes. It doesn't give, it might be because of the misspecification of the model. I have tried other models like GAC 3.2 and GAC 4.2. It works with that one. So one more thing about these GAC-based model. So the conventional unit root test uses least square estimation. And this one, they uses maximum likelihood estimations. So the critical values I'm comparing is critical values for other similar studies. So, and also the critical values of these GAC-based tests approach to the ADF critical values when the sample size increases beyond 500. So my sample size is 2,300. So I'm using that, but I will not rely on those critical values. I'll myself derive my critical values by simulating the data. So that is one thing I have to do. No, it's the GAC model. So one end is GAC model, GAC 11. So that is GAC 11 model and GAC 12 models. So there are different variants of GAC. No, it's not the lag. No, it's not the lag.
So in your policy conclusions at the end, jump to those, let's see the wording there. Yeah, so you're suggesting expanded futures market access. But that's a bit challenging, isn't it? I mean, the two wheat futures markets are both in the US.
Yeah.
Very significant basis risk between those markets and what Australians comes with experience.
Yeah.
Is there another option?
Well, I'm deriving this policy recommendation based on the literatures. When there is inefficiency in the spot markets, the one way of reducing the impact of inefficiency is going to the futures market. I have not actually calculated the basis risk for futures market in Australian prices. So I think it's
I think there is very little use of the futures markets, but I think it's for a good reason. So just, I mean, I guess all I'm saying is try to avoid making a recommendation like that in a simple way. You know, it's a complicated issue, and there are good reasons why it's not already happening like that.
So I think next paper. So we are doing a little bit of this analysis. So I don't think I should be putting this recommendation in my paper, but because one draft, so my supervisor had some little bit of exercise and.
Can we go back to your last structural break, the graph of the 6? So you're saying that December 22, you're expecting it in July.
Yeah.
Well, when you look at the graphs
Yeah.
for the last one.
Yeah.
The sudden spike down is actually before December. In most cases.
Yeah.
So what, I don't know this technique, right? I'm not a statist, I'm not an econometrician, but it seems like the graph's doing what you expected.
Yeah.
But the statistical analysis is not picking it up.
Yeah, like normally what these do is they compartmentalize the different periods in between that year, and they try to maximize the global optimizers. I don't know what that means. And it might be because it was spiking from here and it went here, and there should be some kind of the mean should be somewhere around here. And since it started dropping from here, from the mean during this period, it picked this one.
So it's an artifact of the statistical
Yeah.
method. In which case, just be careful what you say about it, because the comment you made was, well, it didn't really fall until December, but you can see from the graphs that it did,
Yeah, it's around November.
So you want to explain, the approach I take would be to explain what you just explained.
Yeah.
Rather than to say it didn't happen.
Yeah.
When you can see that it did happen.
Yeah.
It's not a sudden switch.
Yeah, it's not a sudden. Yeah.
Switch, so that
Yeah.
The question is, why did it recover?
Yeah.
So the question is, why did it recover?
Yeah.
All those drops that are happening, I can see just before the red line are what you expected to see because they've opened up the Black Sea again.
Yeah.
The market went down.
Yeah.
Why did it then say, actually, we've made a mistake here and correct back up again and then decide to come down later?
So this is what we should be controlling for structural breaks things, because structural breaks are simply the shocks generating from these socio-political, economic, or climatic factors. They have a two kind of phenomena. One is they shift the regime. So if that is a permanent thing, they shift the regime, they take the mean to the next level. Or otherwise, they revert back to the long-term average. So that is not the implicit randomness they are creating. So it dropped here. So this is the point. I would expect this is kind of, I mean, it started decreasing from here. As they pointed out, this should be the October, November thing. So it was coming down here, July, grain agreement, it should be somewhere in July. So from July, it went down. And I think in October or September, there was some kind of, again, conflict. There was dilemma whether that agreement would be renewed or not. So it again started picking up during that dilemma. And this should be somewhere around November 1st week. So November 1st week was the exact date to for renewal of that Black Sea agreement, and that is where it went down. But what this test does is it kind of see the global optimizer thing over that period of time, and when that significantly goes down or goes up from the mean around that period, and that is the point that peaks.
Look like a break.
It kind of like from this, if you see there is some kind of decrease from, I would expect, from the mean, and after some time it again reaches here.
I think it's good also to mention that there are limitations in terms of doing the structural breaks, because what you are using is the buy and that's the best that we have right now, and we can only pick 5 breaks.
Yeah.
So we cannot pick more than 5 breaks. So the statistical, there's a limitation of how far we can push this also for now.
Is it? Sorry, this is another question. The other question that I'm coming to. No, go on. I have a question. Just keep on going.
No, I think it's just you.
Ingredient is.
Yeah. Really. So, it's notable that all the brakes are sort of reasonably the same width. Does the process sort of have a tendency to say, I'm going to try to split this up so it's reasonably in the same groups, rather than deciding if you want to have some really fine. Because I could put brakes on there in lots of places, which look better than the ones it's picked. Yeah, and I just wonder what the process is, and it's a really tight one, perhaps selling it. So I'm just wondering, is there some other constraint which means it doesn't like just saying, I'm going to group lots of, you know. Is it a feature of the process that the gaps are all fairly similar?
So what?
Question I finally managed to phrase.
So from reading the process of this test, what I find is they try to first find the maximum or global minimum. And this is the point that was lowest. That finds the first one. And from here it starts to be. And then by imposing this one, then it finds the next one. And by imposing this one, this finds the next one. If you see, there is some kind of difference in terms of maybe average or mean or something like that. From here, it is the most significant one. This is the point, lowest point. It is picking from here, and it goes to here. It goes to here. It is now coming down this period. So it is now coming down. But again, it went up, but the average was up, but it started coming down from here. So it sequentially finds the break by imposing first one, second one, and so on.
The subsequent statistical analysis do that information. Identify these 5 breaks. How does that influence the subsequent estimation that you do? So one of the difference with the result is like that remains similar. W price and remains similar because that does not change. The trend, including trends, simply loses the unit root properties. But with including this break and heteroscedasticity, the Port Adelaide price and Geelong prices properties change.
Okay, let me answer that question. I think the implication of that is when we are doing this unit root test, if there is a structural break and you fail to include that structural break, then you might end up rejecting the null hypothesis when you're actually supposed to be accepting it. And the implication of that is that you'll be assuming that all the price they revert to the long line mean, and that mean is the same.
The mean moving.
But this is not the case, and that's why this is showing us those means are not the same over time. And so when you look at your model, what we're estimating is the Gauch model. Just go to the Gauch model. So in the Gauch model, now to answer your question, we have to control for those structural breaks. So those structural breaks have been controlled in the Gauch model so that we know that that is taken care of. And now what we are trying to test is to see whether we're still going to have the unit root or the unit root test once we have control of that structural break. So they are controllable. So where we are using them is the DBIs, that's where we are using that information in the model.
Okay, so just testing my understanding is essentially that the mean is changing at each structure.
Yes, that's what
And then you sort of carry on and assume it's just behaving itself until you get to the next structural break, and then the mean changes again.
So if you fail to control for all those things, it's likely that the conclusion that you're going to draw from the parameters that you estimate is going to be wrong. So you may reject the null when we are actually supposed to be accepting.
Yeah, right.
Yeah.
So, so one more thing about this one is like this, without this controlling for structural breaks or heteroscedasticity, the coefficient may look like similar, but there is huge change in standard error.
Yes.
But these standard errors are the ones which is used in computing unit root, and that makes the difference in results. Yeah.
All right, thanks, Udav. Thanks, everyone. We've hit our adapted time limit. So if you would like, we are still, I don't know if there's snacks or anything, but regardless, I would encourage you to go upstairs, eat lunch, interact with other human beings, and have some fun. And thanks for coming to our final seminar. Excellent work again, Udav. And don't turn up next week. See you.